We have with us up here next, Luca Pradovera. He is a principal at Mojolingo.
No longer. Well, technically.
Oh, no longer.
I
Okay.
joined Signalwire.
You're at Signalwire. All right, wonderful. We're going off your bio from last year since this is a impromptu talk.
Yeah.
So he'll tell us all about his new position here. He has 15 years in telephony with a focus on open source software. He was a core contributor to a key Ruby framework. He now runs Mojo. No, you're not at Mojolingo. And he's going to be giving us a demonstration of free switch projects implemented in Signalwire. The name of his talk is Real Life Free Switch Projects. Give us an update on everything you've been doing recently, Luca, and let's have a big round of applause.
So, hello. Thanks, everybody, for coming to this talk and to ClueCon, which has been a great conference so far. So, I'm filling in for another speaker. So, I have lots to say, but the slides won't be up to par, so I'm sorry about that. But we can chat about things anyways. So, my idea has been to look at what we've done recently with FreeSwitch before I joined Signalwire and how we did it, looking at two different complex projects we built. And then see how the new infrastructure we built in Signalwire could have helped us deliver those projects in less time and with higher amount of quality and service. So, what did we build? First thing we built, last two projects we built are a webinar platform for law school training. It's got, so every room has 1 or 2 presenters and 20 to 50 attendees. And each room has real-life interaction with forums and questions, meaning that the teacher, just as I'm talking to you right now, I would say, so you see a quiz pop up, please answer the 3 questions and see and the teacher uses the answers to gauge if what is saying is effective and also what is your focus on, because of course if 90% of people will say the wrong answer to a question, it means you're either not explaining yourself or the subject is very complicated. We do recording and playing back webinars and events, which means that the data is, the video is not only used through WebRTC once, but we're also resending the same videos at separate times through WebRTC with the same events and the same timing of quizzes. So people can be in the classroom the same way as the live event. It has to be the exact same thing in what we call a rebroadcast. So that requires we use WebRTC not only for the live classes, but also for playing back, because as you know, the only way to have low latency for video is through WebRTC. HLS doesn't measure up to par, but we still use HLS in a way I'll show you later. They needed the ability to edit and cut events. So what they do is they have this huge 8-hour webinar, which is in fact usually split in 2 or 3 topics from what I know. And they also cut one of those topics out and just do a mini webinar of just that topic. Customers can purchase separately. And they also needed a way for people to dial in, both through phones, when you, so say you don't have a computer available, but you're required by law to attend this kind of training, you can dial in through the phone and credit still gets counted. Or presenters sometimes have to speak through the phone because, I don't know, hotel Wi-Fi is not working, but people have paid for the presentation, so you have to do it anyways. So it's a complex set of capabilities that involves what? WebRTC and SIP and telephony. The other project we did is a court appearances project. This is pretty interesting because of the security challenges involved. So what happens is that American law mandates that some types of inmates in correctional facilities do not get transported to the courtrooms for hearings, but instead get to appear directly from the facility. That's to save money. Like, I don't know, if the crime is below a certain level, they don't take them to the court, they just let them appear via video. Each one of these rooms has 5 to 20 people, and they need the ability to move to subrooms because it behaves exactly like a physical courtroom. So say the attorney asks to speak to the judge separately, like you would do in a real court, they get moved to a subroom so they can talk, and then they come back to the main room and proceed to whatever they thought about. So we're using a very interesting model here, which is a hybrid MCU and CU to SFU method for support. So as you all know, FreeSwitch has an MCU video mode. So each video gets put in a grid, and every participant to a conference gets the same video feed that's a grid, right? But the mobile support, so mobile support is covered with that, but this particular application is replacing a legacy application that built on Adobe Connect, which has some kind of an SFU type of operation, so you get separate video feeds for each participant. Since we wanted to build this in FreeSwitch anyways, what we did is, in JavaScript, we cut up the video and move so each square of the video is shown separately in a separate element and can be moved around. So there's only one video feed, but actually looks like it's like an SFU. That has some quality trade-offs, of course, but it's a very good solution that serves us very well so far. It's kind of like a ghetto multicast. Like you got one video, it's one feed, and it's split up in the browser. It's performance-wise, it's very good, which is pretty surprisingly, probably because the browser only renders the pixels once. They need, of course, complete control, muting and display videos. Some people need to be muted by the judge. Some people need to be muted by the attorney. The attorneys want to have a way to mute their clients, which sounds silly, but they actually use it a lot from the statistics we have. So the thing that happens most commonly is that the attorney just mutes their own clients so they don't say something stupid. And it happens, so we have analytics on the app. That's the most used feature in the application, which says a lot on how things work. Like, no, shut up. Please don't say anything. And that's cool because in a physical courtroom, they will not be able to do that. Like this, you can click a button. And problem here is interoperability with legacy SIP equipment. Courtrooms have all kind of weird stuff going on when it comes to calling in devices from the 90s, things that don't work with video unless the SDP contains some kind of a nonce generated by the server, because they're only supposed to work with their own servers, right? So all of this was quite complicated. So technical challenges. We do need a true telephony platform. Why? Because we have all of this kind of weird interrupt problems between the SIP equipment. People want to be able to dial in. People want to be able to dial in via PSTN to supply media if they cannot use a computer. Third-party call control is clearly beyond the standard IVR requirements. That is, every call that comes in goes through very complicated dial plan rules, especially in the courtroom example, because we have to really make sure that the user that is dialing and joining a room is actually authorized to do so, and give them the proper set of conference permissions to prevent people to, mute the judge if they cannot or stuff like that. We know, so this is designed to be secure because, of course, people normally will not poke at the JavaScript to get, to mute the judge. So, but you cannot trust people to not do it. So you have to actually be sure nothing happens in that regards. The webinar example is simpler. It's just a case of people having paid for it. So you have to have a way to make sure people that don't have paid, that didn't pay for the webinar are able to join, just because it's, it's money on the table. We need to do playback and recording. So as I said, we need to do many things. We need to record a conference, but we also need to be able to play it back just as if it was happening live. And we need to seek back and forth, and we need to be able to cut the file. So in this particular project, we went with seeking back and forth. FreeSwitch does not record video with markers at close enough resolution in the video to allow you to jump to second defined intervals. So I want to go to minute 13, second 5. So we reprocess those in FFmpeg. It's currently generating huge files. That's something that we're trying to fix somehow, or rather not me, but the people working on the project now are trying to fix in a different way, but that's probably just going to be achieved by reducing resolution. Because as you know, when you're encoding video, if you're putting in time markers, the file size increases because you're effectively repeating the headers that are at the start of the video every second of the video. Makes it very big, but that's not a problem. Real problem here was, and still is, performance and scaling. So 20 people in a room are borderline enough load to kill a $120 instance on DigitalOcean. Because as you know, especially if the video is running in 5K, which is what they're doing here. And the webinar situation has a lot of people joining. We've had webinars where there were 2 speakers, but 100 people joining just to listen. That's a bandwidth issue, not a CPU issue, because there's only one encoder involved, well, two encoders technically involved, but there's 100 people connecting, so that will kill the bandwidth of the server. That is fixable, but the main issue here is that these clients are not prepared, either technically or economically, to set up the large infrastructure they will need to support such a large project if they want to use it effectively. So that's still something they're working on. So what do we use? Essentially, it's FreeSwitch. I don't think I have to introduce FreeSwitch, but does anybody not know what FreeSwitch is? Because I think you took the wrong turn in the lobby. And Nginx is a web server which I've been using in place of Apache for the last, I don't know, 10 years probably. It's a great server. It's lightweight and does a lot of things. And we use it to front it, all of the WebSocket, all of the web requests. And adhesion. Does anybody here know what adhesion is? Yay! 2 people. Great. So adhesion is a Ruby framework we developed to work on telephony projects. This is the only one that needs some kind of an introduction, just because I want to show you where we came from when we designed the next generation of telephony, which Signalwire represents. Adhesion, again, is a Ruby telephony framework. It's based on XMPP mode of operation, so it connects to servers through FreeSwitch through Mode.io, which is an XMPP subset. It's used for IVRs, dial plan, and generally any application. It is effectively a Ruby process controlling the call. So you can do anything you can do in Ruby and anything you can do with FreeSwitch. So hit APIs, call translation services when they're not supported by FreeSwitch natively, ASR, TTS, whatever. You can do anything you want because it's just it's a normal program. It's written in Ruby, and version 3 has been coming soon for the last 2 years. But this time we're going to do it for good, because my good friend Stephen George is helping us. So he's not here, but thank you, Stephen. He's helping us release the version 3 of the framework with many improvements. It's been in beta forever. But main thing is the experience acquired through what adhesion is, and also the lessons learned. For example, Ruby is slow, and the general architecture is a little bit too complicated because it was born out of some requirements. Led us to try and rethink complex application control. Because as you all know, working on an IVR, something like, I don't know, press 1 to speak to sales, press 2 to speak to technical support, is something you can build in FreeSwitch alone. You barely need FreeSwitch for that, because honestly, you could probably do it in something that's even simpler. You don't even need FreeSwitch technically. But when you get into complex situations where there's access control in place, so you need to check against the database if that user or that ID, whatever, is available, or they're allowed into system or whatever, things get complicated pretty quickly. Likewise, if you're dealing with, I have to start playback of a file when the presenter joins, then I have to stop it when the presenter leaves, then I have to record this a certain way, all of the kind of things get complicated very quickly. So many moving parts, really a lot of moving parts. So aside from Nginx, FreeSwitch, and adhesion, each of these applications also has a web app of some sorts, usually Rails, but one of them is Rails, one of them is not. A database, Breed is somewhere, a work queue. We're using Kafka these days because it's all the rage, and also it's very good. There's plenty of small moving parts, and all of the time you're chasing this or that doesn't look quite right, which is a function of this being very complex systems built where nobody had been before. Like some of those things haven't been done before, like the hybrid SFU MCU, for example. On top of that, especially RTMP HLS streaming, which we use to spread out load. So this is a missing slide, I'm sorry. So I'll pretend there's a slide on the screen. So as I said, performance issues are a problem. So what we do is a lot of these cases have people that are participating in the conference, whether the low school example or the courtroom example, but also there's a lot of people in the same conference that are not participating, they're just listening. So what we do is, if you're participating, you're going to join via Verto. If you're not participating, we give you the JavaScript in the browser actually spins you out to a separate server where a stream of the conference being sent via HLS. Listening only people are not answering questions. They're just there to listen. They don't need real-time interaction, so the latency is fine. Like these people maybe have 2-3 seconds of latency. It can occasionally get much worse, like you can get down to 10 seconds compared to the live video, but it's usually fine because they're just there to listen. So they're observers. Some cases, they're journalists in the case of the courtroom, like local journalists. They just give them a link. Go, if you want to see the proceeding, just go here and you can follow it. So we went with that because it's easy. RTMP HLS through Nginx is a solved problem. It's what they use to stream literally anything. Sports, events, movies, whatever. It's all HLS. And top of that, the main problem here has really been having to manage it all. Like the people took over the project, and myself and my colleagues before always spend time trying to figure out why this is not working, why is that not working, why this is not working, why that is not working. So how will we build it now? Signalwire advantages. So what we learned from all those projects, not only myself, I didn't start Signalwire, I'm just helping out, trying to make it the greatest thing in telephony. But I mean, we all encountered the same issues when designing applications. It's a managed platform, so you don't have to care about a lot of things. It can be very complicated to manage. Like just the FreeSwitch fleet, like just spinning up nodes up and down, managing resources. This node is too much load, these other nodes are unused, things like that. And it makes it more cost effective. Ease of scaling, because since it's managed, you don't have to worry about, do I have enough FreeSwitch boxes to run the conference that starts tomorrow? You just have them. They will get spun up or they're already there. And top of that, there's many languages supported by the SDKs which allow projects to be built in more environments and thus allow you to source developers. On top of that, I will say there's also one thing. A managed telephony platform means you can source less experienced developers. Like outside of this room, there's like other 50 people that can build an application like that and starting from scratch. While if you have a manageable API, you can leverage a good web developer and turn them into a telephony developer in less time. So how do we solve all these problems? Mainly with Relay. So you'd like to know, what is Relay? Anybody knows what Relay is? 7 does. Good. That's good that you do. You built part of it. So the Relay is a JSON-based media control protocol based on WebSockets. It handles calls and messaging and the various recording, playback, seeking, ASR, TTS, many other things. Tap, so it allows you to send the media stream from a call into an arbitrary RTP endpoint. Just give it an IP and a port, and it will just send the packets there. Or a WebSocket endpoint, in which case it will be encrypted. So you can use this to easily pipe media into another application. There's various SDKs applications, available, and more to come. Like I built the Ruby one. We have a Node SDK. We have a C# SDK. We have a PHP SDK, and work is getting started on a Golang and Python SDK. So this effectively will take the place of Adhesion early. So you'd have a WebSocket application spun up. It will listen for calls. So a call comes in. There's a consumer example. So this consumer is written in Ruby because it's my favorite language, and it's registering a context. What is a context? Context allows you to group your application logically. So if you spin up 6 consumers, all with the same API keys, they cannot all be, well, maybe you want them to all get the same calls, but maybe some of them are for an application, some of them are for the other. So incoming is one context. That's just a string. So I'm registering on incoming context. At that point, when an incoming call comes in, the incoming call method gets called. So I'm now noticing that I should then name the context differently. So the context is incoming, but it could be inbound. The method is always named on incoming call, just to clarify. Then you get a call object you can interact with very easily. So as you see, I'm answering the call. Then I'm playing the usual keyboard test phrase, the quick brown fox jumps over the lazy dog, and then I'm just hanging up. All of this is 7 lines of Ruby plus some boilerplate. Of course, you need to include and stuff, but you can have a whole consumer fit into 20 lines of code. This gives you the power of programming, and in any language your developers or you know, but coupled with the ability to do complex interaction with calls. This is just an example. You can dial out, you can join two calls, you can split the two bridges apart so they go back to park, and many other things. You can send SMS, you can send MMS, you can send and receive fax, you can do machine detection. There's even other stuff I don't, really it's moving so fast I might be missing some features, so come talk to us if you'd like to explore this. All of this is already released. Of course, some of the features are in beta, some of the features are ready. You can do this right now. You can just set it up and go. And you will see it in action later in many dangerous demos, including my driving a car demo, where you all will get to move a car around sending SMS to a number. And hopefully the car will move. But if the car doesn't move, it's the car's fault, not Signalwire's. The system actually works. It's the car that's the problem. Great. So, well, thank you very much. It's been. I'll keep it a little bit shorter because I've been asked to, because there's dangerous demos coming up. So we'll all have to wear our asbestos underwear to make sure everything is safe. And any questions, I'm here to help. Any questions you have after the presentation, just come talk to me, please.
My question is around the consumer context and my availability.
So if you're spinning up multiple consumers, they all get the event. First one to respond cancels the others. Yeah. At the protocol level, the others get informed that they don't need to handle the call no longer.
All right, big thanks to Luca for doing this talk on short notice. He was filling in for another presenter who couldn't make it. And so big round of applause to him for a great talk and for helping us out.
Thank you.